Hey guys, so it's time to add some behaviors to our objects. We talked about objects having attributes and having behaviors. The attributes are the instance variables. So for our circle class here, it's radius, color, and x and y. But this circle can't do anything on its own. That's what methods are for. So a method, I'm going to define a method here. We've already seen a method before. We've seen the main method. Here it is. This is my main method in circle main. It's got some special, it's kind of a special method. It's got some special stuff about it, which we'll eventually get to. I can define a method like this. I have to give so let's do the example from the guide here. So there's a little Python Java back and forth here because we haven't really looked at methods officially in Java yet. So this is a Python function that adds up three numbers. Or adds up three of whatever it's given, since it's there's no types specified. Here's the equivalent for integers in Java. So this is the name that you declare a function or a method by giving a name, and before that, instead of the keyword def, we give a type, and the type indicates what this function is going to return. It's going to return an integer. And then we can define the three variables, the only difference being that we have to declare what type they're going to be. So these are actually three variable declarations here, A, B, and C, for values that are set when we call the addup method. And then here I'm adding them up and I'm returning the result. So here, let me show you how this would work over here. So let's go int addup. This isn't a very good method for the circle class, but it's just an example like this. And then I can go int d equals a plus b plus c, and return d. Okay, so I'm really leaning heavily on Python here. I'm assuming that you guys understand how to pass parameters, how functions work, how to return a value, and so on. Now that I've added this method to this class, I can call it from over here. So I'm going to leave all this stuff in there. But let's just do system out print line /n/n video2 /n/n like this, and I'll go system out print line c, just one of my circles, dot add up. Notice it's giving me help here. It's reading my own class and saying, oh yeah, you can do add up 3, 4, 5 like that. Okay, and it's giving me these annotations and everything, showing me which variable names I'm putting those into those values. So when I run this now, the last line that comes out here should be 12. 3 plus 4 plus 5 is 12. So I pass 3 to this function, and it's passed by position, so it goes into the variable A, 4 goes into B, 5 goes into C, and the return value, we come to here, this method executes, creates a local variable called d, and then returns that value, which goes back to here, and d is 12, and it replaces this, and we print out d. So I'm hoping that all that seems fairly familiar. The only real difference for right now for Java is that we have to declare our variable types for our parameters, and we have to declare the type of the whole function. And we have a special type here. So you'll notice what's going on over here in the main method. If we just ignore public and static for a moment, it's type and then name, and then this is obviously a single parameter called args, which has this weird type. Something about strings, but it's a little different from what we've seen before. I'll let you guys take a guess as to what that might be. But this is the type, and the type here is void. So there is a special type called void, which you can use when the function is not going to return anything. Okay, and when we comment methods, by the way, we use Javadoc. So /** gives you this. So I can just put example method to add 3 ints, and then you notice it's added these tags for me. Param a, I just have to fill in first number to add. I put in a one line here, explaining each one, and then it returns the sum of A, B, and C. So there's my full documentation. The documentation is longer than the method. Okay, but that's not the way that we normally use methods in Java. We use them to get objects, like circle objects here, to do stuff. So here's an example. Let's say I wanted to get, I might want to get some information out of this object. For example, I might want to get it to compute its area. So that's one of the examples that's in the guide. I can create a function for that using its radius. Let's put it up here actually so that we can see the variables while we're doing it. The function is going to be of type double. I'm going to call it get area. Notice the use of camel case and the lowercase letter to start the function name, the method name. Now you might think if this was procedural programming, if this was like a Python program like you were writing last year, you would need to put, a variable here for the radius. We would need the radius as input, but we don't need to do that because we are inside an object. Okay, this thing can't get called unless somebody's created an object of type circle, and then they can say c.getArea or whatever, and it will call this getArea, and this circle already knows its own radius. So we don't need that piece of information, and you'll see this a lot in object-oriented programming. You end up writing a lot of small methods that have 1 or 0 parameters, have very few parameters. So getArea is just a prompt that we want to return. What do we want? It's pi r squared, right? Math.pi times radius. And notice the coloring here. The purple, and when you click it, it actually shows you what variable this is referring to. So if I had put double radius here, I can do that. Notice that it's turned black to match this one. Now I have to pass a parameter, and it's going to compute the area using that radius. This is a local variable radius, which is hiding this class level variable radius, this object level variable. I don't want to do that. I want to do this so that I'm using that variable there. So now that method is created, I can over here go system out print line c.getArea. What is the radius of C right now? Looks like C's radius is 999.9, so it's going to be a big number that comes out of it. We'll do a system out print line here just to create an empty line, and we'll run this. And there we go. So there is the area of my circle. And if I create a new circle, circle D equals equals circle with the radius of 50, I can do system out print line c.getArea like that, and it will print out a different area. Whoops, sorry about that. New circle, not just circle. There we go. So that creates another object in memory of type circle. Oh, I did it again. Used the wrong variable. Do you guys see my error here? I created a circle called D. Notice it's grayed out here. That's actually a little visual clue. It's telling you, it's not really putting it in your face, but by making it gray, it's telling me, you never used this variable. Are you sure about this? Same thing over here. See, that's why color is gray, because we never actually use color down here, and we never use it in main either. So it was trying to warn me without getting too in my face about it. But I wanted to do d.getArea there. And there it is. So 2 different areas. Okay, so you can use methods to get the class to do something, to do some computation on its own variables. You can get information out of the class like this, out of the object. You can also use these methods to get information in. So for example, I might want to set a new radius like this. And in this case, this is what parameters are for. So I need to add a new radius here. We'll call it a new radius like that. And now I just go radius equals new radius. And notice the coloring again. So I'm passing in a new value here called new radius, which I am now attaching to that one there. And I think and I've got an error here. It says missing return statement. I accidentally put this as type double, but this is an example of a method that doesn't have to return anything. We're not asking for information, we're providing new information. I think I have an example too of set location, double X, double Y, like this. And we can set 2 things here. Sorry, I'll call these new X and new Y. and we'll go x equals new x, y equals new y, like that. Okay, so now we have these methods that set things. I can go d.setRadius 100, and then system out print line d.getArea, which should reflect the change, and d.setLocation, and for this I have to give it two values. Let's say 10, -50, like that. Oops, forgot my semicolon. And then I can go system out print line d.x. Let's just print x to show that it happened. Okay, so I change the area again to 100, and I get this new value, and then I'm printing out the location. So instance variables are for holding information. So this class creates an object called circle, and a circle knows about itself. It knows its radius. It knows where it is. It knows what color it is, and it can tell us stuff. So it can compute its area and tell it to us based on its radius that it knows. We can also tell it things. We can say, you know what, you moved. Now you're at this new location, and so it says okay, and it updates its x and y to be that new location. This add up really doesn't belong anymore. Pay no attention to that method. That doesn't belong in this class at all. It has nothing to do with circles. It was just an example that I was showing you before. I want to show you one other thing, and this is kind of cool, is that we can, another thing you might want a circle object to do is draw itself. So you can have a draw method, and if we pass it a graphics context object like this, then we could do, now what we want to do here is we want to import the graphics context class. So I just added the import up here. This is so we can have it draw itself. And we could have maybe the x and y as the center location. So we could do a gc.filloval. Well, it says circle, so maybe it's stroke oval. Stroke oval. And the x is going to be x minus radius, and the y is going to be y minus radius, and then the size is radius times 2, approximately. There we go. And it draws, now this thing draws itself. Now we can't access that method right now. What we need is the FX graphics graphics template. So I'm going to go back into week 1 here, into the example code, and find it. I'm going to copy it, and I'm going to paste it in here, but I'm going to change its name to circle graphics, like that. What did I do? Not sure what I just did there. I think I did something wrong. Let me try that again. So I'm going to copy this, paste it in here. Yeah, I should give it a new name. Circle graphics, okay. No, it doesn't like that. It didn't, I expected it to automatically change this, but it didn't. So circle graphics, I have to change that. It should have automatically done that. I don't know why it didn't do that. But remember, the class name here has to match the file name over here. So what do we do here? Well, we can just create a circle here like this. Circle C equals new circle. And then we can now get it to draw itself. And we have to tell it where. So this is the graphics context object that we usually draw on. We just do c.draw, and it should, Control-Shift-F10, should work and should draw itself. Now it's drawing itself at location 0, 0. So that's why it's coming up in the corner there. c.setLocation. Let's go to 100, 200. So x of 100, y of 200. And let's do a set radius of 35, make it a bit smaller, and then we'll draw it again. I haven't implemented the colors here. Might be interesting to think about what that would take to implement the color. There we go. So first it drew itself over here, and then we moved it and changed the radius, and now it's drawing itself over there. Cool, huh? So I want to show you over here. So we've been looking at instance methods. There's a little comparison here. In procedural programming, functions are for subtasks. But in object-oriented programming, they're for a particular behavior, and that behavior is always related to the instance variables. So we don't end up passing as many arguments, we don't have as many parameters to our methods, because a lot of the time, most of the information we need is inside the class. So the draw method doesn't need to know its radius. Where are we? Here. Doesn't need to know the radius of the x and the y location, because that's all stored inside the circle object. All it really needs to know is where do you want me to draw it. So we just pass in the context. Get area doesn't need any information. It's got all the information it needs to compute the area and return it. Okay, so we're using methods. It's the same functionality, but in a different way. Return values are for sending back information from the object. So if a behavior changes an instance variable but doesn't need to tell the calling program anything, we might not need to send back a return value. Okay, I do want to show you, this is circle 2. This is in the sample code. So let's take a look at that over here. So circle 2 in the sample code has get area, set location, and a draw that is a bit more fancy than the one I gave you. Circle 2 test over here is based on the FX graphics template. So it creates some circles, uses set location, sets the radius, and draws them. Control-Shift-F10. So it's a pre-baked version of what I just did. Yeah, it displays the area here, and it creates like a little bullseye picture. Oh, I see what I've done in circle 2. I've set the line width proportional to radius, which is kind of a cool effect, because so the bigger the circle, the bigger the line width. This also has another interesting method in it that I wanted to point out, the equals method. So you know how strings, you can't just do does s equal t with a double equals, it won't work. We went over that at some length earlier. It doesn't work for the same reason why you can't do that with circles, and we went over that in the last video. So if you want to check if two objects that you created are equal to one another, you have to provide a method that does it. So this is a Boolean method called equals. It returns a true or false value, and it takes another circle as a parameter. Now the type of the circle here is called circle 2. So the first sections is circle, then there's circle 2 for section 2, circle 3 for section 3, so that you can see all the different stages. So we're passing in an object, and I call it other here, and then we just compare our x to the other's x, and our y to the other's y, and our radius to the other's radius. And in this case, I'm saying if they're all equal, then we're going to say these two objects are equal. If there was a color, you might want to check the color as well. So we can actually tell whether two circles are equal, quote unquote, to one another by calling the equals method. So if I go to circle 2 test, I can ask for my two circles here. Let's do a system out print line of that. I can go c dot equals d. And I think that the answer here should be false, because yeah, false down here, because C and D have different locations. Actually, same location maybe? Yeah, same central location, but different radius. But if I then were to set C dot radius equals 100 to match D, I can do system out print line C dot equals D again. And let's compare that to system out print line C equals D, like that. You see, so I set the radius to 100, which means that they both have the same location and the same radius, and now my equals method returns true, but the double equals returns false, because they're still two different objects. So system out print line C and system out print line D will show you that they have different memory addresses, which is why this turns back false, but they have the same contents, which is why my equals method returns true, because I am returning the result of this Boolean expression. Okay, and I wanted to show you this because it's an example of passing an object to another object's method. So I'm asking for a parameter here that is of the same type as the current object. And I'm comparing my x to the x of the object that was passed in, and so on, to decide if they're equal or not. So this creates a situation of aliases. I have in the main program, circle2.test, I'm doing c dot equals d. So d is a is a reference to an object. I pass that reference over to here, and now other is a reference to the same object D in the other program. If I was to change other here, so if I go other dot radius equals 100 here, that'll make this turn false, but also it will change the radius of D in the main program over here. So, oh, it's already equal to 100. So let's make it equal to 1,000. So I'm going to change the other's radius to 1,000. And then over here, after I do c dot equals D, I'll go system out print line D dot radius. Let's do it before and after. So let's run this. So where were we? Yeah, so before d dot radius was equal to 100, and then of course they're judged to be not equal because over in circle 2 here I actually changed its radius, so it doesn't match. And then I printed the radius again, and the radius of D has changed to 1,000 because we ended up in that situation where let's do a full screen snip here, and then we'll draw on the screen. So we have D like this, which points to an object with a bunch of stuff in it, including radius of 100. And then over in the other method, so over in circle 2 class in the equals method, I have a variable called other, which holds a circle. And what's happening here is by calling the method, I am passing this value over to here, which means that this other variable is pointing to the exact same object. So that when I did other dot radius equals 1,000, I changed this to 1,000. And that's why when I print d dot radius down here a second time, it shows up as 1,000. Right, so that's what's going on there. Yeah, so I keep hammering home on this whole reference variable thing because I think it's really important to understand. And I hope that you guys are starting to get it a little bit. Okay, I think that's it for the guide. And let's take a look at the exercises. So in the first exercise, I had you pick one of these objects and model it with a UML diagram. Now I want you to add some instance methods to it. So if you picked, for example, the TV, well, what are some behaviors that a TV can engage in? So something that you can do to a TV or something that a TV can do. And I give you some ideas down here. So bank accounts you can deposit, withdraw, print a statement, get the interest, and so on. With squares, you can get their perimeter and area, you can draw them. TVs, you can turn them on and off, change channels, change the volume. Students, you can get their grades, you can get their final grade, you can show a report card. Video game players can take damage, heal, move, display themselves, and so on. Okay, so I want you to, whichever object you picked, add some methods to the UML diagram. So that means in that third box, oh yeah, I didn't show you that part. So over here, here's an example. Yeah. Here's the example here. So this class, Circle 2, before I messed with it, still had 3 instance variables, but it had the following methods. Get area, which returns a double. Set location, which takes 2 parameters called new x and new y, which are doubles, but doesn't return anything. Draw, which takes a graphics context parameter, doesn't return anything. And equals, which has a parameter called other of type Circle 2, and returns a Boolean, returns true or false. I should have put the GC on here, but this is another style. Sometimes people don't specify the names of the parameters, they just specify the types. Looks like I kind of mixed and matched here. Probably I should have put GC : graphics context on there. Okay, so what I want you to do is add to your UML diagram some specifications for the instance variables, what the instance methods, what they're going to be called, what parameters they're going to take, what types, and what type they're going to return. Your instance methods should all start with a lowercase letter, just like your variables. Only class names start with an uppercase letter. And yeah, and then implement that stuff and test those methods. Okay, so implement the methods and add code to your main method to test them, just like I just did in front of you. Oh, and I do want you to include an equals method. I want you to try that out. We will have a method a bit like that in the coming assignment. Okay, that's it. This was a bit longer than I thought, but they're going to get shorter. I will see you in the next video.